Hey everyone, hope you all are having a fine day, and well, it's the last talk, let's go for beers after, so here it goes. So the talk of turnkey code is basically when we go for the concept of turnkey and we bring it a little bit to the code. And the concept of turnkey is just something that is ready for immediately use. It's mostly used on houses, so when you have a turnkey house, it's something that you just buy and can go just right and go into living there at the moment that you buy the house, and that concept also appears a little bit on the code itself. And first of all, let me present myself. My name is Diogo Lemos. I'm a security engineer. I've been working with security for over 5 years in different companies. I started on Checkmarks and joined Blip-Flutter, and now I am at OLX. So, introduction to Turnkey Code. Turnkey Code is basically the same thing as Turnkey, but when you bring it to the code. So it's code that is ready to go, it's immediately accessible, and well, the passwords are already in the code. You don't need to do anything. You just start code the passwords directly into the code. Well, it's faster for development because if the passwords are already in the code, it's faster for doing everything. You don't need to go to configure the passwords. You don't need to configure anything. Everything is just already in the code. You don't need to go look to a password to connect to a certain app or a password to connect to another app or usernames or anything. You just put everything into the code and it will work as fine, I expect. It's easy to share around. When you want to share a password for application that you have, you don't need to use some private bean or Slack secrets or anything like that. You just put the password directly into the code and then you do a git commit and the password will be on the repository. And that seems okay, isn't it? It's also simplified debugging because everything will be in the code, so it's pretty much a little bit more easy to do the debug itself. And in the end, it has one reduced dependency setup because you don't need to configure Vault or any secret store or secrets manager because eventually you'll put everything into the code and the things will work fine. And well, it's faster, isn't it? It's better, and that's a good approach. But well, that's not exactly. So when you put a lot of turnkey code, and believe me, your companies, I'm almost sure that they have some turnkey code in there, it brings a lot of issues itself. And it brings security breaches because dark code passwords will be into the code, and if one person has access to the code, then the passwords will be there. It also gives a little bit of exposure because if you have a public repo with some code in there, the passwords will also be in there. So if someone gets access to your GitHub or GitLab, they will have eventually access to everything. It's pretty much more difficult if you have turnkey code to rotate secrets because the secrets are there into the code. You don't need to change them in a certain platform, and that's quite more tricky, I would say, than if you have a password manager that you just rotate the password in one place and it will rotate for everything. If you have in the code, maybe you need to replace it into 2, 3, 4, and more. And it also brings a lot of compliance violations, and we can all agree on that. It increases the attack surface because everything is in the code. If someone wants to have a look at your company, they just go to the code and, well, most probably they will have access with passwords or secrets and anything like that. And it brings a lot of lack of access control because, well, everyone can be an admin if they just go there and look a little bit. And well, we have a little bit of turnkey code in our organizations. We need to do something about it. So, okay, what can we do to fix the turnkey code? We actually go for secret scanning. And secret scanning is basically finding secrets and passwords and tokens hidden into the code. And it actually needs to be specific for secrets because secrets are passwords because it will find only that thing. And that's one of the misconceptions because nowadays we are seeing that traditional SaaS solutions actually bring a lot of more effort into finding passwords and all of that. But the secret scanning itself is meant to be as a complement to those solutions. Because when we think about secret scanning, we think about finding some kind of secrets and things like that, and it needs to have some kind of entropy to check if a secret is valid or not, because otherwise you will just have hundreds and hundreds of results, and most of them will be false positives. And you also need to go, mostly important, to have a comprehensive analysis, because you need to go to the Git history, because the issue in secret scanning, most of the cases are not the new commits to where you already have your vault or something like a secrets manager configured. it's that old instance of GitHub that you migrated from time to time, that has a lot of repos that should be archived, maybe should be removed for a long time, and the passwords are still there. And most of the cases, they are not even on the recent commit, they are just there on old commits, and well, you need to do something to find them. And it also mitigates a lot of risks and strengthens the compliance. So, what we need to make secret scanning work and then having no more turnkey code, we actually need a tool that will be responsible for doing the secret scanning. We actually need also repos, a place where we'll run all the scanners, and we also have to have some kind of tool to import the results. Otherwise, we'll just have hundreds of results and we can't do anything on that. We just need to put them in a platform where developers can go there and check if everything is good, do some triage on results, and well, things are improving in that sense. So what we need to choose a tool for doing the secret scanning, we need the tool to be properly built. So it will find things like password, API keys, secrets, tokens into the code. It needs to have some kind of detection methods, and that's a big plus because as much as you can reduce the false positives, that's a win, because developers will go to the tool, they will triage the results, and if you have less results, they will be more happy, I would say, triage those. And it also brings to the table pattern matching, which in the end will bring a lot of less false positives, and also validators. So immediately check if a password, a GitHub token, or something like that, it's valid or not. Because if you have the information that it's valid, you just don't need to do the tries. You just need to go there and rotate the secret, and that's it. And it also brings the comprehensive search that I was talking about, that will go into the Git history and find the secrets that are there in the end, because you can, in the current code, you may not have secrets, but in old commits, there might be a lot of secrets in there. It needs to have some kind of customizability, because the secrets on my organization may be different from your organization. Every organization is different, and you might need to set up a new set of rules to find another secrets. And it also needs to support multiple code bases, because in a large-scale organization, you kind of need to have support for GitHub, GitLab, because there are things always moving around and you have code on both places. So if you have a tool that can run the scan in there, well, that's a big plus. So one tool that actually does the trick is Truffalog. It checks all the boxes, and it's pretty much easy to install. You just do a brew install or you do anything, and it actually works very good. You just do like a Truffalog Git and you pass the Git repo, or you can just also run it locally and something like that. And well, you have there immediately the validator to check if that token is valid or not, and that's a big plus. And the tool itself is pretty much easy to work with. And then you actually need to have the repository coverage. And one misconception is also that when you do secret scanning, you put the secret scanning the first time on the CI/CD pipelines, and that might work, but I guess the end goal of it is to have at least the first scan into scanning the whole infrastructure, because otherwise those old repos and those old commits I was talking about might not even be in the new CI/CD process. They just might be there lost in archives or something like that. And if you just go for the currently CI/CD process, you just lose all those repos that are there. And if your company be GitHub or GitLab is exposed, those will come to the mind, and most of them might have passwords valid in there. So you need to check everything, you need to scan everything. One tool that we actually use that works pretty much good with it, which isn't in the end built for having all the repos in there, it's source graph, it's actually built for you can search things into the code into GitHub, GitLab at the same time, or even more. But it also keeps a shallow clone in there. And then if you run the scans into source graph, you can actually have scans for your whole thing. So, well, that's a big plus, and the tool itself, it's open source. We actually use it for free, and well, it's a nice one. And well, you need to import the results somewhere to somehow you need to do the triage, because even if you have hundreds of results, you need to do something with the results. And there's a tool that I actually work with, and it's built by current and past employees of Blip and Flutter, and it's also open source. It actually doesn't have support for secrets right now. However, I already created a pull request. It's up for review, and you also can check out my private GitHub, and there's a fork of that with secret scanning. And basically, the tool is just a tool that is written in Python Django and correlates and syncs data from several data sources and things like that. You can just import everything. You can create a model, and it will have an application itself that I will show in a bit. And the tool actually is pretty much good because it has an SCA built in that, and it's quite a funny module in there. So what we need to the process, we have turnkey code. So let's apply what we learned from before. We'll do the clone all the repos that we have, we'll do the scan, and then we'll import the results into security surface. And well, that should be it, and we'll have no more turnkey code once the developers go there and review all the secrets. But well, it was not quite like that, because that thing that I talked about of the entropy that reduced false positives also was creating a huge blind spot on results that I guess most of the results shouldn't be in the code, and most of them, the first time that we looked, and okay, this is just test files or comments or things like that, but they were actually, most of them, valid passwords and valid secrets. So we actually need to do custom rules to find the secrets, because it's like I said, a secret in our organization may differ from your organization. And the last thing on there, the red one, is like Truffalog also doesn't scan for sensitive files, and we actually noticed that developers put sensitive files, P12, JKS, on the GitHub or GitLab and all of that. And even though they are not exactly secrets, they are sensitive files, like the name said. And well, if you can do some work and some rules to catch them, well, great. So we refine the process. We now do a clone, and we can use SourceGraph, like I said, to have all the repos in there. We'll do the scan with the Truffalog rules, and then we do new scans. One, to catch all those results, and Truffalog has the customizability that I talked about to catch the new rules and find the other passwords and secrets that were missing. But also we do a scan to find, like, do a git log to find those sensitive files that I was talking about. And then you kind of need to have another thing, which is the improvements, because it's like you import and for some reason, Truffalog has that thing called entropy and pattern analysis, so you don't have much false positives. But when you scan all these results, like API keys and passwords equals to Portugal in that case, you'll find a lot of results, believe me. So in the end, you need to go in there, remove false positives. What we actually did was, if it's from a test file or from node models or something like that, cases that we know that are not valid passwords, if it's comment or something like that, remove those results. Otherwise, there will be hundreds and hundreds of results for the developers to try, and they won't do it, believe me. So you need somehow to remove the secrets, and also you need to remove some kind of duplicates, because a secret might be a secret into several locations, but in the end it's the same secret, and the same thing applies for the sensitive files that I was talking about. So you can have the same sensitive file, the same P12 file, into several locations on the same code. And what we actually did on that is, okay, we'll create an hash of each file and then compare it if it's or not the same, because if it's the same, we'll not create a new secret, we'll just create a secret with the hash of that file and then compare if there's any more places with that file. And well, in the last part, we just import the results into some solution where we can do the triage itself. And well, this is the current solution. It's actually running on my machine, but you can set a surface on yours and do those things in there. I actually have most of the information in the Git repo, so take a look in there. But well, the tool looks like this. You have the secret. It shows what type of kind of secret you have. It shows the source, where it came from, and it shows a repo. The sources are a direct link to the, for example, that secret is on Truffalog. If you click on one of those 5 sources, it will link you directly to the Git repo and also to the line where the secret is directly into the code and in the commit that you want. You can have the status and the criticality to do the triage yourself, or the developers in the end. You have there to check if the secret is valid or not and if it's verified. And the location itself is one thing that I will show you right now, because like I said before, you can have the same secret, and that's the secret, and you have it in 3 files. So you don't create 3 more entries, you just create 3 more locations. So that secret is on that 3 files, and well, that they actually are on the same commit, but well, that's there. And you can also say, like I said, the sensitive files, in the case this is one of .mobile provision, but it's the same thing because it's on that repo and it will have 2 locations that secret is. So the first part, the secret, is an hash of the file itself. And well, the work is not finished because here you expect the developers to go here and triage everything, and in a mature state, you probably won't have many results and many passwords here to triage, but the work is not finished. You just don't do this process and everything is okay. You need to keep on doing new things and things to mature your secrets management state. And there are 3 things that you can do, and I think they are the most important ones after you do the first part of it, which have set up a pre-commit, set up a pre-receive, and set up CI/CD scans doing the secrets at the same time. And you actually, the best thing is to have all the 3 implemented, but each of them has its own limitations, and if you can just put 2 of them running, well, that's good. Because in the end, the pre-commit, it's good because it catches the secrets even before they go to the Git repo, but at the same time, they need to have some developer buy-in. The pre-receive hook is actually one of the most smart ones, I would say, that requires less effort, but at the same time, they are ideal for a self-hosted environment, so might not work with most of the Git update for all organizations. And the last one, CI/CD scans, okay, but the secret in this case will already be into the Git repo. So when you get to the CI/CD, you will have just to rotate the secret on doing something like that, to before prevent the secret itself for being in the Git repo. But if you have on the CI/CD scans, that's good, but well, developers will also complain that you are putting more time into the CI/CD pipelines, that you are doing more results, maybe you are blocking things, so that's a thing. You need to improve on the free. The best is to have the free. If you cannot have the best of free, choose what's best for you. I have actually practical examples of this. This is a repo that you can also check on my GitHub, and it's like an example for Trufflog on the pre-commit, and this is how it looks. You do a commit of a file, if it's all checks a box, in this case, just look for the Trufflog one, but if it's passed, it will be committed to the repo. But if it's not, it will be failed and the commit won't even go through. So there will be a secret and you need to remove the secret in order to do the commit. This also can be set up on the CI/CD using the workflows, but yeah, it's all the same thing. So key takeaways, and this is like a small presentation, but I think it's important to point out these 5 things, which is you need to scan everything. You don't just not do secret scanning into the current CI/CD pipelines. You need to scan everything that it's in your code, because will be those repos that are archived that you don't look for several years, that has secrets or passwords in them, and believe me, there will be secrets in there. You need to do the triage, I would say. Of course, it's hard for push the developers to do and to triage the results, but results will come every day. Every day developers are doing code, the results will go up in there, and you need to do some kind of triage. And, well, you can enforce at all stage. That is the long-term goal, and that's like the holy grail, but, well, if you cannot do at all stages, maybe do at some, best than nothing. You need to be proactive, because one time or another, your GitHub or GitLab will be exposed, or kind of some repos or things like that. And if you are not prepared before, you will have a big issue in that, like a little time frame to retweet everything. So you need to do this before your GitHub is exposed. And you need to stay consistent. So repeat the same process, triage the results, import new results, implement the hooks or the CI/CD if needed, and well, everything is like that. So this is a quick one. If anybody has a question, feel free to ask. But, well, that's all, folks.